Excellent. So my presentation today is, if you own a multifunction printer, then I own you, or potentially own you. Obviously not all of them are bad and not all of them are being used in an unvulnerable fashion. But in today's presentation, we're going to be discussing multifunction printers and hacking multifunction printers and stealing data off multifunction printers, corporate and home office type style systems. I'm from the Dayton, Ohio region. I come down here every year with a bunch of my friends. I've been in IT for 18 years. I've been in security for 8+ years, and 3 of those years I've been working as a security pen tester, assessment engineer, that type of stuff. I'm a member of the FUFASnet team. If you're familiar with that, that's the group that puts out the Medusa and FG dump tools. And this is my 4th year presenting at CarolinaCon. It's just actually killer. I enjoy coming here every year. So no one's ever hit me with a beer bottle yet, so hopefully we'll make it through this one too. Hopefully they can run fast if they miss. So let's go ahead and get started. In today's agenda, we're going to be talking about multifunction printers and their functions and features, and what those functions and features mean. We're going to talk about attacking multifunction printer devices, the why, when, how, and leveraging the data that we gather off these devices. Of course, we're going to have a few demos. I don't think anyone has ever seen me do a presentation without demos. Those are always fun. So we've got 2 or 3 simple demos to make the point here. Oh, geez. Good thing I got sunglasses on. And then we're going to talk about the tool that we released earlier this year called Prayetta. So let's go ahead and get started on multifunction printers, functions, and features. So what is our ultimate goal? Our goal is to be able to leverage data off these printers that can be used to carry out attacks against other corporate systems. And the type of features that we're looking for on printers are an example are like email, the service settings, the address books that contain usernames, that may contain passwords. We're going to show examples of those. Faxing services that contains contact information, usernames. Again, usernames are half of the puzzle in a brute force attack, so they're of value to an attacker. And that information can be pulled from address books. We're also talking about the scanning functionality. A lot of these multifunction printers, you can walk up to them and they have what's known as scan the file functions. That means you can put a sheet of paper or whatever you want to scan on there, hit scan, and it'll actually store it somewhere. It'll store it on a Microsoft file server, it'll store it on an FTP service server somewhere. So we're looking at those settings, system settings, user settings. Also, a lot of these devices interact with LDAP. The ability to walk up to some of these large-scale printers and authenticate yourself to that device. Well, how's it able to do that? It integrates within the corporate's LDAP server in some fashion, and the only way it can do that is it has to have some way to connect to it. It actually has a username or a password to authenticate itself potentially to an LDAP server. So we're looking for those type of features and functions. Logging is always a wealth of information. There's a lot of devices out there, specifically collar printers, that log enough detailed information you can do chargeback functions. So it'll actually log the user's network username into the logging system every time he does a print job. And of course, the remote retrieval of print, scan, or fax jobs off these devices could also be of some value. So first thing we're going to do is we're going to start looking at some of these features on some of the more large-scale multifunction devices out there. In this case, we're talking about a Toshiba eStudio. So this is underneath the administrator screen. If we blow that up, we look at some of the setting functions that are here. Examples, the network settings, email settings, which may contain information for SMTP to be able to authenticate to an SMTP server. Save as file, which was this data back here, which is a scan the file function, which contains information that could potentially be used to log onto a server to store the data. Internet faxing, haven't dug into that one, that sounds interesting. And various other functions and features that exist on this device. The next one, real quick one, is Canon Image Runner. If we blow up these services over here, we can see the additional functions that we have on these devices. Register your LDAP service, as I mentioned, so this contains username and authentication information stored on the printer to connect to the LDAP service. Other cool settings over here, if we go further down to the import-export, this is the ability to do a full backup of various stuff off the printer. It may be the configurations of the printer. It may actually be address books and various things like that. So we're actually going to show how this export data can be used to retrieve a lot of this core information that may be of value to attack a system. The Xerox WorkCentra Pro, there's millions of these out there. I'm seeing more advanced models coming up every day. And here we also have, as we explode up this screen, various settings. Under protocols, we obviously have SNMP. You know, if a company actually configures, as an example, an SNMP to be no other than public or private because they want to manage it in some fashion, what's the chance of that new community string being used on other systems within the organization? So that's data that could potentially be used to attack with. Also, SMTP services, it's highlighted down there. That would obviously be a connection into the email system, and it may contain authentication information so that faxes can be sent out through email or receive emails for faxes and stuff like that. We go on to another screen within the Xerox and we come down to the cloning function. And this is a really fascinating function. The cloning function is the ability for the printer, let's say you have 50 Xerox printers you need to deploy with you throughout your corporation. Do you really want to log into each one of these and configure them? Well, you don't have to. You can actually do the cloning function, make a snapshot of a configured printer, and deploy that out to as many systems as you need to over the wire through the printer functions. So I think this is the last one we're going to touch base on from a configuration standpoint is a RICO. Again, this is very similar to the other printers that we've looked at, same type of functions and features. It has logging, email, connectivity to the SMTPs underneath there, file transfer, the ability to authenticate, transfer files to systems. And we also have LDAP services as an example. These devices authenticate to an LDAP server. Pretty much all the same type of functions and features. Now they're implemented and secured in various different fashions on each printer. But our ultimate goal is to rob, steal, cheat, and plunder these things as much as we possibly can. So let's go ahead and get into that. Attacking multifunction printers. So why do we want to attack multifunction printers? And I've said it a bunch of times already, gather information. We want to escalate our rights into other core systems within a corporation. One of the easiest paths to do this, and the one that's most likely to be ignored, is through the web interface on multifunction printers. So when are we going to do this? If you expose them to the internet and you say, why in the hell would anyone expose a printer to the internet? Obviously, you haven't Googled the internet for printers. It is horrifying the number of printers that are out there, and it's even more horrifying the number of printers out there with default passwords still set on them. As an assessment engineer, I don't normally find these printers set up exposed to the internet. It's more of what I see during assessments. If I do a college or university, they have this open thing about them. They like to make everything free and open to everybody. In those cases, I've seen multifunction printers exposed to the internet. The other thing is you know, or once you gain foothold into an organization, as a primary example of this, it was only like 2 weeks ago during an assessment from the internet, I was able to get a username and password and authenticate to an SSL VPN for the company. Well, that was the very limited access. All I got was their extranet web page that told things about the company and what employees needed. But it turns out it was a Juniper using a pass-through portal that hadn't configured right. So basically all I had to do was pass internal IP addresses to this portal, and it would attempt to connect over 80 or 443 or 8080 or whatever that web service was. So using information gathered from another web server, identified the internal IP addresses, put together a script, and started playing it against their Juniper, and it basically started looking for web interfaces on the internal network. And I soon found their entire printer subnet. Was able to crawl through about 30 different printers and retrieve vital information that actually helped escalate more access into their core systems. So that's a foothold approach. You get a single foothold, it's limited, but if I can read printers or access the printers, game over in some cases. And the other thing is, you know, you're just sitting at work one day and you're bored as hell and you just want to screw somebody over. Uh, those are the type of people that may go after these things and look at the printers. Unfortunately, or fortunately, a lot of times they've been ignored up to this point right here. And I have been generating all kinds of noise about multifunction printers. I mean, we're all so familiar with this thing. You've been hearing it over and over. It's been on CNN. Oh, printer hard drives, copier hard drives. Everyone's running around going, oh dear God, we're losing all this information, and they still totally ignore this stuff here. Well, hopefully I'm creating enough noise that's going to change, and people are going to start paying more attention to their multifunction printers in their organizations, and we're going to get a better security out there, which is what the ultimate game is. It's not insecurity, it is security. So how are we going to attack multifunction printers? And we're going to discuss these here today. Obviously, leveraging default passwords. We're all familiar with that. If you put a printer in place, you don't change the default password, you have access that way. Access bypass attacks. We're going to talk about that. Information leakage attacks. Once I gain access, where do I get this information from? Forceful browsing attacks, very similar to access bypass attacks, but a little different. A passback attack. And we're going to talk about that. I won't go into much detail on that right now. And also backup and cloning functions. We're going to dig into those with a couple demos dealing with Xerox cloning functions and their downloadable module creation process. So default passwords, most area of major fail, and we're all familiar with this. How many people in here have all the passwords on their printers at work even set and changed so they're not the default? That was about as many as I had raised at SHMU. So it's a prime example. You got a very small percentage, and that's what I find during assessments. I find most of the time the printers have no password set, or it's a factory default password set on it. So now I do have access. Where do we get the passwords? Product manuals, always a good source. And here's some links down here. Of course, we'll make these slides available. These links can go to some password databases that are available on the internet, and you can pull passwords down. And at this point, I think I've memorized half of the passwords for most of the printers out there, but not all of them. That's my goal. Okay, the next area we want to is talk about bypass attacks. The ability to bypass the authentication of the device, basically by twiddling with the URL, passing weird stuff to it, various changes in the URL request to make the device go, oh yeah, sure, here, you can have my content. We have two examples. One is a Toshiba, and the other one we're going to actually demo with the OfficeJet. And on the Toshiba, if we look at this is the URL that you would pass to a Toshiba printer. And when you do this, it's going to redirect you over to the login.html or HTML. And in this case here, the password would be 123456 by default. But if that doesn't work, well, what do you do next? Well, it turns out that what I found out was purely by accident. So how many of us are real commonly will cut and paste URLs, right? You cut and paste, and we're doing testing, we'll cut and paste, cut and paste. Well, I was doing a cut and paste, and I inadvertently left the extra slash in there between top access and administrator. And believe it or not, it took me right into the system without any required authentication. So that's kind of an interesting one. Now, the other one, we got a demo here, and this is an Office Scan, OfficeJet HP device, and you see these. A lot of people buy these down at Best Buy or whatever. But it turns out that I run into these in corporate America a lot. People love to put these in their office. They're inexpensive. I don't know how much data you can get off these or how much integration they do. The various models have more and more integration. But this particular model had some issues, and I want to show that to you, dealing with a bypass attack. So we bring up the screen here. It's fairly straightforward. This is the home page. It redirects you to the CAD info, print info. If we try to go to some of the settings, setting and networking, if you try to go to those fields and there's a password set, it prompts you for the password. The truth is, I don't have a freaking clue what the password is. I changed it so long ago, I forgot. But the stuff I'm going to show you today, you really don't need it. So So you just hit cancel, and I don't know if everyone can see that URL. I tried to explode it up bigger. But see, it goes to the unauthorized. So if we cut this out here, page equals fax address book 1, and just paste it back in so that we have a page equals fax address book 1. It bypasses the security, gives us access. The funny thing about the whole thing is between the first and second page equal, you can basically put anything you want, and it still works. I'm not sure of why it's doing that, but you have to have at least 2 page equals to get this thing to work. So easily can bypass and get access to about 90% of the settings on this device. There's a few things you can't change without the password, and that is the actual password. But why the hell would you want to? There's no need for it. Okay, let's go ahead and move on to the next section, and that is information leakage attacks. So we've gained access, what next? Okay, well, default password gives us access. We've found methods to bypass the security on certain devices. Where do we take it from there? How do we gain access to this data that we're after? So the first one we're going to look at is the Toshiba. So let's go ahead and explode this up. So we have this down at the bottom of the screen. It's real simple. Key pieces of information. If you see in the URL, there's 2 slashes in there. So I bypassed the security to get to this particular page, which is a scan the file configuration page. So we have in here, we have the server name and the server folder structure. Here we have the Active Directory domain name and the actual username. And down here is that infamous blah, 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 blah that we all are gotten so accustomed to looking at. The thing is, though, has anyone really paid attention about what's sitting behind that, especially when you're dealing with embedded systems? Actually, it's the password. So if you right-click on that field and would go, in Firefox, right-click Properties, you're going to go right to this, and in plain text, the password is existing. I have yet to find a modern multifunction printer that did not put it in plain text. A few years back, about 3 or 4 years ago, I did find some that were actually base 64 encoding, but that's pretty much lame too. But they don't bother doing that anymore. It's just plain text. So then we move on to the actual image runner. This is fairly similar type thing. If we explode this up, and we get the username, the password, and those nice little blocks again, and the domain name. This one's a little different. When you right-click on this, go Properties, it will take you to a whole bunch of black dots. But if you follow the data out to the end of the line, it made a Java call. You follow that Java call, and it takes you down to these hidden tags where we have the plain text password again being stored. So never assume, kind of look at the code, follow it through to make sure that they have not obfuscated in some bizarre, stupid fashion. The one thing I missed to talk about, I think it's important. On this particular one right here, the engagement I was on, this particular Toshiba printer was actually being used by the payroll department. So you want to guess what they were scanning in? Payroll documents. You want to know what the worst part was? They were nice enough to restrict this user. He could only get access to this folder right here. And he could get access to anything within the domain that was everyone, because every time you create a user, he's a member of everyone. But they restricted, he could only get access to that. But they were nice enough to actually store all of the full payroll system backups in that same folder for me. So I basically quickly downloaded the 5 gig payroll system, extracted it out, and pulled down, I think it was like 1,500, 2,500 employee credentials. And it was pretty much everything, their bank account information, payroll deduction information, social security numbers, everything this person owned. And it was available, fully accessible because of a printer being used in the environment. So the next one we want to talk about is forceful browsing. This is the ability to, if you know what the URL is, you can just enter it straight in and not follow the normal path of access. And we actually have, in this example here, I like to point out that it's common that the most common file types are usually properly secured. Things like .cgi, .htm, .html, from a security standpoint, typically are properly secured. So you try to get to those through forceful browsing. The security mechanism on the device will usually grab that. But on devices that use other file names that don't fall in these normal styles, it's not unusual to be able to just retrieve those through a forceful browsing and have it just give them to you. The other example is it's very common to find some web pages that are accessible through links on a secure page. So you try to get to this page, it's secured, but if you had access, the links aren't secured. So if you know what the links are, you can go straight to them, bypassing their lame attempt at obfuscating insecurity. So we have two examples here. The first one is the image runner, which is an unprotected file type. And the second one, we're going to do the office scan right here, where we're talking about a forceful browsing by, we can't get to the secure page, but we know what the URLs are, and we can actually trigger some operation on this device by just injecting right into the URL. So the first one is the image runners, and it turns out the image runners have, by default, 11 address books. And to get access to these address books from a forceful browsing attack, you have to have a valid cookie. So you can get a valid cookie by authenticating, but on some models, all you have to do is hit the home page first, and it will give you a valid cookie. And then you can do forceful browsing to the actual files, the address book files. In this case, if you look down at the bottom, we're looking at .ldif in this particular case. So I hit the home page, and then I can query the various address books straight up and have it give me that information. So here's one of the address books from an actual engagement. We pulled it down, and everyone goes, well, address books, what value are those? But the image runners typically contain other cool information. We explode this up, we can get the actual URL, we can actually get the username, and we can actually get a password. Now this is kind of a scan to file function. The user comes up, his name's D. Smith, he authenticates the device, it validates him through LDAP. Now if he does a scan to file function, it's actually going to store it in this location, and it's going to use these credentials to carry out that function. Probably out of 20 or 30 companies that I've actually pulled this information from their systems, I'd say probably about 20%, 15 to 20% of the time, I actually find more than just usernames in email addresses. I actually find some form of password being stored on those image runners. So then we get into the HP Office scan, and this is an interesting forceful browser. Like I said, these devices are used in a lot of offices. The cool thing is you can find about 50 or 60 of these on the internet. And several years ago, a reporter, I think maybe it was last year, a reporter actually reported, one of the internet reporters, he had one of these, and he found out that you can trigger the scan bed remotely on these devices. So if this device is on the internet and you expose it to the internet, anything you leave on the scan bed is potentially accessible. And the first thing he said was, you need to secure these printers to protect that, or we're going to blow a hole in that for you. So if you have one of these things out there and you have it secured, that isn't going to work. Just don't leave anything on the scan bed. So if we come over here to home and we come down to the web application web scan, if we try to trigger web scan, it prompts us. In this case here, it doesn't have the page equal function. It's at the root of the URL. So they've properly secured this page, at least up to this point. That doesn't mean there isn't some other screwy problem with it, but I haven't found it. So we get to this point right here. So I have some cut and paste because I'm lazy. So there's two operations. There was originally, you had to make this query to the printer off that page, and it bring back a server status code. And once that status code come up, there was a post operation you had to do. But it turned out that you really don't need to do the post operation. You can just pass it as a standard GET. So if we go ahead and trigger this, trigger the scanner. Hopefully this will work. Now your Visa card's up there, man. So if you have one of these, just remember that it's not secured. There's no way to properly secure that scan bed. I find these in a lot of corporate offices, and it's amazing the things you may find on these scan beds. Mostly it's not work related, it's usually personal related, is really common. Someone, it's medical stuff they need to file, or it's stuff they need to file at work or with their insurance company. That seems to be the common thing. I find a lot of insurance papers being stored on these things. So the tool we released, Preta, actually has the module built into it to automate doing this. So. Okay, the next attack we want to talk about is a pass-back attack. This is kind of a new approach. This was actually completely found about a month ago. One of the guys that was working a security engagement said, "Hey, Daryl, I found a bunch of RICOs on the internal network I'm at." He set up a tunnel for me. I tunneled into that company and started playing with these printers. The whole idea of a pass-back attack is tricking the printer into passing data to me that he would expect to pass to some other service. In this case here, we're doing with LDAP settings. So if you go into the RICO LDAP screens, and you click on, in this case here, they have one called Company Directory. It's set up in the LDAP. But you can have up to 5 of these. So if we click on this, it takes us over to various configurations. I think we can expand that up so everyone can see it. So here we have the server name, we have a search base, a typical LDAP port number, SSL's off. Oh, come on, so if you're going to use this, use SSL on. Authentication on, username's LDAP admin, so turns out it has a lot of rights to the LDAP server. And then we have a thing called password change. It's a button. So if we click on this, we get nothing. We have the ability to change the password that it uses to authenticate to the LDAP, but that's not what we want. The one thing we're after is at the bottom of the screen. It turns out they have a connection tester. So what it does is if I click this button, the RICO printer will go to the LDAP server, and it'll authenticate to the LDAP server and basically give a response back saying, "Hey, this connection's good." So let's play with it. Let's go ahead and change the IP address on that configuration. Let's test the button. It comes back and connects to us. We have a listener, and the password is printer187. So now we have full access to their LDAP server with LDAP admin in their environment, easily by tricking. The cool thing about this is we're not finished completely testing it. It turns out that, if we come back here real quick, all the pieces of data here, except for the password, are actually sent in the post operation. So the testing that I need to do, being an assessment engineer, you get limited access to these devices. So I'm waiting for another series of RICOs to get access to. I have a friend that works at a company that supposedly give these to me. I theorize that if we pass this data in the URL or in the post operation, that's the way we could do the server's IP address. We don't necessarily have to change it on the printer. And that way, instead of making modifications to a device, triggering it, we just send it to the device in a post operation, and it'll just make the correlation with the right password and send it back to us. That's some testing that's left to be done, and I have a strong feeling that's going to be the case. Okay, the next part we want to talk about is extracting information from backup data. A number of multifunction printers provide a method for doing backups or cloning operations. These functions provide a method to quickly deploy multiple systems within an organization. As I mentioned earlier, if I have 100 printers to deploy, do you really want to go to 100 printers and configure them? No. You cut a clone or some kind of backup, you deploy that to the other printers. And Xerox has built-in functionality specifically for doing that. In this case, we're going to look at a Canon and we're going to look at a Xerox. So the first one we're going to look at a Canon, kind of an older one. It's the Image Runner 3030. They have several different things you can back up. They have address books, and we know there's data possibly in address books. Forwarding settings, additional functions. The additional functions are the ones that should contain LDAP settings. They're core settings within the system. So if we click on that, we come over to additional functions, and these are all the capabilities that will be pulled on the additional functions. So if we click actual export, it'll export a backup of the configuration. If you use this, be patient. It is very slow. It runs, oh gosh, takes 5, 10, 15 minutes based on how much configuration has been done on the device. It'll generate a file called usermod.umd. This is stored at the root of the URL. So if someone's run it in the past, you can forceful browse it and pull it off the system. This is not a ASCII file. It's actually a data file. So it cranes all kinds of stuff in it, but there's some ASCII string data in it. So if we explode that up, you can see in the string data, the username and password are in plain text. So in this particular devices, you're able to pull that core information out from a backup of the device. The next one we want to talk about is the Xerox. In the Xerox here, obviously it's a cloning function. If you click on the cloning function, you can see all the features that are available there. And you basically click clone. And what it'll do is it'll create a file called cloning.dlm. The DLM is a, let's see if we get a picture of it. We'll show it in a minute. That's also stored at the root of some devices, some Xerox devices. And if it's been run in the past, you can forceful browse and gain access to that file too. Some of the newer ones also put a timestamp in front of the cloning, so you can't do that. But still, if you get access, you can run your own cloning file. You can pull the information down. So let's go ahead and actually look at these cloning files, because this is important. So we've got two examples to look at here. So if we cat a cloning file, you can see that it's really no readable data typically in the cloning file. But there is some readable data in the header of the cloning file. And it's the structured header that's been put on there by Xerox. I was doing some research and searching around, and I found a Norwegian website where a couple of these tags showed up in the data on the site. The site was all in Bork, so I didn't know what the hell they were saying. I found a good converter and converted it from Bork, and it gave me some interesting information. It generally came out and said, and it happened to be a Xerox employee in that region of the country, and he said basically that this is a custom tarball, compressed tarball file with a custom header on it. So the theory is you rip the header off, you should be able to untar it. Hold on. Let's clear the screen, get it up to the top. Sorry about that. And easy enough, we're able to extract the data out of this file. The cool thing is they use the same cloning functions, if anyone's interested, in their actual firmware upgrades on some of their devices too. So you can get all the data in the firmware. So the cool file we're interested in here happens to be under the data segment, and it's a CFG clone. So you can see basically everything in these files is generally plain text. Let's go down, see if we can find some passwords. So you go to all the different settings, and most of them have no password set. They're not configured. Here we got one for SMTP with a password of milk.5. We come down here, and here's the LDAP completely set up with what's up, and the password was milk.5. This is your typical cloning files that are devices that are out a couple years old, okay? They've actually done some attempts to actually secure this, and I'll show you what that looks like. We haven't cracked it yet, but we are heavily working on figuring out what the mechanism that's being used here. But let's go ahead and go to example 2 so that we can show that. Very similar in structure, a lot of useful information, even if you don't get the passwords. You can see the LDAP password happens to be 32 character hex, which makes us quickly think that it's possibly a hash. But the truth is, if this is a cloning function, remember this file has to be transferred to multiple devices. For that device to be able to authenticate to whatever the LDAP is, it's going to have the plain text to be able to do that. A hash is not reversible, so it can't typically be a hash. So we know it's some form of encrypted. Not sure why. The cool thing is I do have all the programs that are used to trigger the cloning operation. So hopefully we can figure out what that is. And we also know a lot of these devices, the newer ones, use Ingress databases on the printers within the operating system to store all this data that's pulled out. So is it being encrypted inside the databases? So there's a lot of key things that we need to figure out yet. Unfortunately, this printer that this came off of is like a $20,000 printer, and no one's going to lend me one. So it's a very short burst of knowledge that we gather, and it's constantly building on the big picture. And hopefully we will get to that point where the light goes on and we know exactly what's taking place here. At that point, we'll probably release that information as part of our tool, Praeta. Earlier this year, we released a tool called Praeta. Praeta is Latin for plunder, thief, robber. And that's what the tool does. Its whole goal is to plunder your printers for possible usable information. My team uses this on a regular basis. We're always constantly trying to improve it and make it better. And it contains a printer module, so it looks for printers. It does check the default passwords for a couple network appliances. The ultimate goal is to incorporate also various network appliances also, because they suffer similar problems. I regularly find network appliances with default passwords on them, cameras and stuff like that, and a lot of those devices integrate with other systems. At a minimum, SNMP is a standard integration, one engagement, gained access. SMP string was the same one that they were using on all their firewalls and Cisco routers. So we quickly gained access to all that stuff because of a camera that was configured with an SNMP. But the tool is beta, or I'll be honest with you, the tool is barely beta, okay? It's not really buggy. It's written in Perl. I wrote the code. The code is, in my opinion, I kept it very simplistic. There are some coding methods that I used, or structure methods that I used to build this, that may be a little strange to some people. But when I was researching how to modularize this whole thing, I just felt comfortable going in this direction versus, it's Perl. You can do the same thing 365 different ways. And this just happened to be one of those 365 different ways of doing things. And the goal was to create a simplistic tool. And generally the tool is made up of 4 general parts. You have Praeta PL, which is the dispatcher. The way the dispatcher works is you feed it a target list of IPs of printer devices. And what it'll do is it'll crawl through those IP addresses, querying the title page and the server type. So we have a file called data file. In the data file, as you can see, we have a sequential list numbering on the left-hand side. And then we have the next tag area is actually the title page. The next tag area is the server type. We find out that it's a fairly reliable fingerprinting method on these type of, or on most embedded systems, because they want to tell you what their product is and what model number it is and all that type of stuff within that key information. And then the last part is actually the modules that have been written to do information gathering and web page gathering and parsing and all that type of stuff. So the Paretta will use the target list. It'll compare it to the data file, and if it gets a match, it'll run the modules. And that's simply how it works. So at present, I think I could get this wrong because there's two different versions. There's a release version and an internal version, which isn't quite been released yet. But I think there's like 28 different variations of modules. Now, when I put this thing together, because the fact that as an assessment engineer, I gain access to your Xerox, it may not see that model again for 3, 4, 5 months. And I may find the next engagement a model very similar, but the query method and the page may be slightly different. I ended up creating a different module. And the purpose of that was because there's no way to go back and retest the older system. So if I make changes to incorporate multiple variations, my fear was I would step on myself and clobber myself. The goal is once we get this thing big enough and get a big enough test base from people playing around with it, we'll be able to collapse a large number of these into modules that pulls the address book and pulls this and pulls that from the printer and covers a half different variations of a Canon printer versus having 4 or 5 different modules to actually do the same thing, and that way we wouldn't step on ourselves. We're also looking at migrating over to Ruby. We got a couple base Ruby versions that have been written, but we haven't gone through and vetted them and tested them and all the variations and stuff. But the ultimate goal is if we can get this thing structured, working successfully on a large number of systems, that it could eventually be incorporated in a Metasploit. That would be the ultimate goal. We're also working on HP and Xerox encryption methods that they use to encrypt certain backup data files, as I showed earlier. And generally, I work for FUFASnet, and we're actually hiring. So if anyone's interested in getting a job as a pen tester, we're looking for a developer. Doesn't have to know pen testing. We'll teach him to pen test, but we're looking for a developer. So if you're interested, shoot your resume to jobs@fufas.net. It'll be later this year. And that's pretty much a presentation. Do we have any questions? Oh, come on, no silence, that's no good. People playing with the tool. Play with the tool, write modules. I mean, they're really, really simplistic Perl modules. Just grab a web page and it parses data is generally what it's doing. Or if the device actually exports something, you just trigger that export and gather that data. So you can easily look at these modules and create new ones. Tell us what the printer is. Or if it generates error message or brings back garbage. Sometimes if an error condition we haven't seen before occurs, you may end up with a whole page of HTML when it should have just said in the log file, a password or something like that. So those type of things would be good. Anyone has any $10, $15, $20, or $30,000 printers they want to give me, that would come in handy, which is unlikely. Any other questions? Yeah. In my opinion, I think Xerox is making an attempt. Since I started this project, I started it last year. I was actually, before SHMU, I did an interview with MIT Tech Review. That was picked up by MSNBC. Since then, I've done two interviews with printer industry trade magazines. So the goal is I want to get everyone doing it. Can I say one's better than the other? If they have patches, are you installing them? That's the question. Because they are releasing patches. Toshiba contacted me after SHMU and said that they had a patch. They were supposed to follow up with a phone call, which they didn't, so I'm not sure there. They thanked me, which they probably shouldn't have, but so there's potentially a patch out there. for that security bypass. Yeah. Oh, you're talking with the card access system on them? I have not had a chance to experience those. I see those are a lot of times being used in military government installations now on a large scale. But unfortunately, I haven't done assessments which gave me access to those type of things. It may be fascinating, you know, what would the security implication be? I'm at the console on that device and I'm required to authenticate with a card, but if I can go in through the web interface and rip you a new asshole, what do we solve? It's pretty bad. And we've only looked at the web interface so far. There's other resources or other interfaces on these printers. You know, they run an SSH and Telnet. In these large systems, Xerox and Canon large systems are running actually a Sun OS on a Power PC. So it's a full-blown operating system. Yep. There's several different things. One, do pay attention to patch management on the devices because most of the stuff I showed you with Canon doesn't work on all the devices. So my surmise is that there's a patch for it or a new version out there. The other thing is change default passwords or set a password and make it a real password. You know, something associated with a campus name just doesn't work as a password. The other thing is look at what the printer's being used for. When we're talking about the printer on the payroll system, why is that accessible by some schmo that just plugged into your network? Why isn't that isolated and only access to those type of resources? So if you do that, you set the password, do a pass management, and set the printer up for what it's going to be used for, I think you can actually secure yourself fairly well. That's, to me, that would be a real overkill. I think that if I plant my butt on your network and I plug in, there's probably about 300 other ways I can own you from left versus using a printer. This is just one of many. This is actually when we do this on engagement, it's what we do the last day. Usually the first day we have your domain admin accounts already. I don't think there's a case that hasn't been the case. But any other questions? Yeah. Yeah, if you want to do like a Paros or a Burp proxy capture of a transaction of usable data, clean the data, please. Yeah, don't send me your passwords. And don't do that against somebody you legally do not have access to. I don't want that data either. Yeah, man. You have to speak. Oh, yeah, he'd asked the question earlier, it was a similar question, and I'd mentioned that Xerox, in my opinion, seems to have a focus in that area, but we still have to have the end users educated. You know, they can build all these features into a printer. If they're never utilized by the end users, what's the point? If I can gain access and I can make mods to your printer, and you know, if I can gain access like this, what's the next step? I can pretty much pull anything off the hard drives in some cases and all that stuff. Xerox doing all kinds of cool things. They're doing full disk encryption and all kinds of crazy things. So I think they're doing the right thing. They're moving in the right way. And I'm hoping the noise that I've created will get the other vendors moving in the right direction.
How do you get people to let you test their printers?
I'm actually,
Not let us.
right, I work as an assessment engineer, pen test. So, you know, they pay me to come on their site and assess their security. So
I do the same thing. They say printers are out of scope.
you got to be kidding me. Why would they say printers out of scope? Now you definitely don't want to run a scanner against a printer like a Nessa scanner. Oh, that does something. You run Nessa scanner against this thing, it pukes all over itself and starts flashing. And most of the printers will do that. So if you run Nessa scanner against printers, they're actually going to start spewing hundreds of pages in lockup. That's a guarantee. Because you remember when you hit port 9100 just takes whatever hits it and prints it. So if Nessus just feeds it garbage, it's going to try to print it, and then it causes all kinds of crazy things. Yeah, but it's a denial service. You know, yeah, There's a lot of open area here for bad things that can be done, because you know what, a lot of devices, I'm not saying which ones and how many, but the actual firmware upgrade, you can just send it to 9100 and it'll process it and do a firmware upgrade on certain devices. Yeah, because if you look at a lot of the firmware upgrades, they're actual all framed up in PCL. They're PCL jobs. Yeah. Yeah. Most of them will just pretty much do that. Yeah, it's a potential attack vector. But the thing is I'm sure I will never convince anyone to let me test this on their $20,000 printer, nor would I try to. There's one back here, yeah. You speak up? You know, I have not yet. I did some experimenting on these devices and some of the variations of the Office Jets and some of the other models. You could actually hit the device remotely across the internet and go to the configuration page and check the wireless. It'll actually pick up all the wireless in that area. So if you get past the device, you know, I've always theorized if I can connect to a device somewhere close to me on someone's network, well, what's the potential of getting it to connect back to me while it's physically connected to the network? Is there any way to carry an attack there? And there's always a possibility. I know some of the printer companies will not allow the wireless and wired ports to be up at the same time. And that's how they've tried to fix that, but not all of them do that. Yeah. What was that again? You can say that a little louder? No, I have not. The firmware I have not done yet. I haven't played around with any injection attacks like that. So far, we have a lot of things on the big list of nasty things I want to do in life. And right now, we're just trying to get our way through all the web interface stuff. You know, it's like everything's laid out to me. And once I get to the point where I have that under my belt, and then, oh yeah, we're going to move on to some other cool capabilities all the way. And I've said that, and I've had brainstorming sessions with people about attacks with firmware upgrades that would actually load on these high-end systems all new code, you know, exploit code, tunneling code, scanning code that can be triggered through the web interface. So we've sat down and brainstormed and thought about that. So there's a lot of attack vectors associated with these printers, but that I have not done yet. I think we're pretty much out of time.
Let's give Deral a hand. Wasn't that fantastic?